Okay, so you want to level up your Python game. You're in the right place. Today, we're diving deep into something that trips up a lot of people. Like, how does Python actually talk to files?
It's a fundamental skill,
Yeah.
whether you're wrangling data, setting up configurations, or just making your scripts way more powerful, knowing how to make Python read and write files is kind of essential.
Yeah, it's one of those things you can't really avoid, but honestly, digging through all that documentation can be a real pain. So, what we want to do today is cut through the noise and give you like a clear roadmap to file handling in Python.
Right, made it practical, make it something you can use right away, no matter what you're working on.
Exactly. We've been digging into a bunch of resources, articles, tutorials, all that good stuff.
And there's one function that keeps popping up again and again,
Yeah.
the open function.
Yeah, the open function. I feel like that's the key that unlocks this whole world of file interaction. So before we get too far into the weeds, maybe we should take a step back for a second. Like, why even bother with files? Seems pretty basic, but what's the big deal about reading and writing files in our code?
It's all about this idea of persistence. I mean, think about it. Your Python program, it runs, does its thing, calculates stuff, maybe shows you some results, and then poof, it's gone.
Right.
Without files, all that work, all that data you were working with, it just disappears.
Vanishes into thin air.
Exactly. So file handling is kind of like giving your programs this long-term memory. It lets you store information permanently in a file, and then later on you can bring it back to life, pull it back into your program, and do something with it. That data doesn't die when your program ends.
Okay, that makes a ton of sense. So you're saying this open function is like our starting point. So how do we actually use it? What are the crucial bits of info we got to feed it?
So the open function is how you create that connection between your Python script and the file on your computer. It needs, at a minimum, two things. The first is file name, which is just the name of the file. Pretty straightforward, right? And the second thing is called mode. And this mode argument, it's really important because it tells Python what you're planning to do with that file.
Okay.
Like, are you going to read from it? Are you going to write to it? Are you doing something else entirely?
So you're saying like what kind of access we're going for?
Exactly. You set the
Yeah.
permissions. And when you call this open function correctly, what it gives you back is this thing called a file object. Sometimes it's called a file handle. And this handle, it's like your tool, your interface for actually doing stuff with that file.
So we've got this file handle. We do whatever we got to do with it, read, write, do our file magic. And then what? I vaguely remember something about needing to close files when we're done. Is that right?
Yeah, you're remembering correctly. That's like being a good citizen of your operating system.
Yeah.
So once you're finished with a file, it's super important to close it properly using the
Yeah.
close method.
Okay.
And there are a couple of reasons for this. First, it's about resource management. When you open a file, your operating system sets aside some resources to handle that interaction. When you call close, you're telling the system, hey, I'm done with this file. You can reclaim those resources now. It's like being tidy, cleaning up after yourself.
Makes sense.
And the second reason, it can actually prevent some nasty data surprises because of something called buffering. Sometimes Python might hold on to data temporarily in memory before writing it to the actual file.
Okay.
Closing the file makes sure that any buffered data gets flushed out, like ensuring all the ingredients make it into the dish, so to speak. It just guarantees that nothing is lost.
Gotcha. Open, do your thing, and then always close it up. Now, you were talking about these different mode settings earlier.
Right.
What are the common ones we should be familiar with, ones we're going to use most often?
Absolutely. So the mode really determines the type of access you have. Let's start with R, which, as you might have guessed, stands for read. This is the mode you're going to use most of the time when you just want to get information out of a file, like read some data or configuration settings. And what's cool is if you try to open a file in read mode and it doesn't exist, Python won't just silently fail. It'll actually give you an error message.
It tells you.
Yeah, it'll let you know, hey, I can't find that file. Much better than just wondering why things aren't working right.
For sure. Informative errors are way better than mysterious silence. So, what about when we want to put data into a file? What's the opposite of read?
That's where write mode comes in, and it's represented by W. When you open a file with W, if that file doesn't exist, Python will be nice enough to create it for you. But, and this is super important to remember, if that file does exist, opening it in write mode will completely overwrite anything that was already in there.
Oh, okay.
It's like starting with a clean slate every single time.
Yeah.
So you got to be careful with W to avoid accidentally deleting data.
So W is like wiping the board clean and writing something new. What if we want to add to a file without erasing everything that was there before.
Ah, yeah, that's a common scenario. That's where append mode comes in. A for append. When you open a file in append mode, any new data you write will be added to the end of the file so it preserves what was already there. And just like with W, if the file doesn't exist, Python will create it for you.
So A is like adding a new page to our file's story.
Exactly. It's great for things like, let's say you have a log file, you want to keep adding entries to it. Append mode is perfect for that.
Perfect for logs. Got it.
Mm.
Now, I also noticed a mode called X. What's that one all about?
Yeah, X is a bit more specialized. It's for creating a brand new file, but it's extra cautious. If you try to open a file in X mode and it already exists, Python will actually throw an error.
Oh, wow.
That's like Python saying, whoa, hold on. There's already something there. I don't want to step on anything.
Like a safety net.
Exactly. And this is super useful in situations where you absolutely don't want to overwrite anything accidentally, especially if you're working in a team and multiple people might be messing with the same files. It's a safeguard against data loss.
Okay, so that's the lowdown on the main file modes. Now, our guide also mentions these things called text and binary modes.
Right.
What are those, and when do we need to think about them?
So by default, when you open a file in Python, it assumes you're working with a text file.
Yeah.
That's represented by the T mode, although you often don't even need to type it out explicitly because it's the default.
Okay.
And in text mode, Python helps you out with things like how characters are encoded and how lines end. It makes things easier for working with plain text.
But sometimes you're dealing with files that aren't text.
Exactly. Sometimes you've got things like images, audio files, or other specialized data files. And in those cases, you got to switch to binary mode, which is B. In binary mode, Python treats the file as just a raw stream of bytes, no special interpretation. It just moves those zeros and ones around. And yep, you can combine these modes. So WB, for example, would be for writing binary data to a file.
Like when you're saving an image from your program.
Exactly. You'd be working in binary mode.
Okay, so we've covered the modes. Now let's actually get to work. Once we've opened a file for reading, how do we extract the information we need?
So the simplest way is to use the read method. If you call read without any arguments, it'll grab the entire content of the file and give it back to you as one big string if you're in text mode, or as a bytes object if you're in binary mode.
Okay.
It's super convenient for small files when you just want to get everything at once.
But what if we've got a massive data file? Loading the whole thing into memory doesn't sound like a good idea.
Yeah, you're right. For huge files, or when you want more control over how much you read at a time, you can give the read method an optional argument called size. This lets you specify exactly how many characters or bytes you want to read in one go. It's great for just peeking at the beginning of a file or processing it in smaller chunks.
Now, I noticed our source material really emphasizes reading files line by line. Why is that such a big deal?
Reading line by line is super important, especially when you're dealing with larger files, especially text files. And Python gives you a few ways to do it. There's the readline method
Okay.
that grabs a single line from the file, including the new line character at the end. If you call it repeatedly, you get each line in sequence. But honestly, the most elegant way to do it, the most Pythonic way, is to just use a for loop directly on the file object.
Ah, interesting.
Python treats an open file as something you can iterate over. So in each step of that loop, you automatically get the next line. It's clean, it's readable. Now there's also this method called readlines that reads all the lines from the file at once and puts them into a list of strings. This is handy if you need to jump around between different lines later on.
Makes sense. So we've got options depending on how much data we need to handle and how we want to work with it. All at once, in smaller chunks or line by line.
Exactly.
And I also saw some references to what they call specialized reading techniques. What are some real-world examples of when we might need to use those?
These techniques usually involve combining the basic reading methods we've talked about to achieve some specific goal.
Okay.
Like, let's say you only need the first few lines of a file. You could just call readline a few times or use a loop and break out of it after you've read enough lines. Or imagine you need the last few lines of a file. A common way to do that is to read all the lines into a list using red lines and then just access the elements at the end of that list.
It's all about being flexible, tailoring your approach.
Exactly.
Okay, so we've covered getting data out of files in detail. Now let's switch gears. Let's talk about putting data in. How do we write information to a file using Python?
So writing to a file usually starts by opening it in write mode, W, as we discussed earlier. Just remember, this will wipe out any existing content, so be careful. Once you have the file open, You use the write method to send the string you want to write to the file.
You said string. What if we want to save numbers or other types of data, not just strings?
That's a great point. In text mode, the write method expects a string. So if you have data in a different format, like a number, a Boolean, or a more complex data structure, you first got to convert it into a string using the string function.
Okay.
And in binary mode, you'd need to convert your data to a bytes object before writing.
So we got to make sure we're feeding the right kind of data.
Exactly.
Now, we talked about the append mode, A, for adding to a file without erasing what's already there. How does the writing process differ in append mode?
It's actually the same write method. The difference is that whatever string you pass to write will be added to the very end of the existing content. It's perfect for building up data over time, like with log files, or adding to a list of records without disrupting what was already there.
Makes sense. I also noticed that the write method gives us back a value. What is that?
It returns the number of characters that were actually written to the file.
Is that something we need to pay attention to?
It's good to know, but you might not use it in every single file operation. It can be handy for debugging, though, or for keeping track of exactly how much data you've written, especially in more complex scenarios.
So we're opening the file with the write mode, using write to send our data, remembering to convert it to the right format first. What are some best practices, some do's and don'ts that we should keep in mind when working with files in Python?
The number one best practice, and our source material hammers this home again and again, is to always close your files when you're done with them, using that close method we discussed earlier. Because forgetting to do this can lead to what are called resource leaks. Your program might hold on to those file resources for longer than necessary, and in some cases, it can even lead to data corruption or data loss. It's a bad habit to get into.
Yeah, definitely sounds like something we want to avoid. Is there a way to automate this closing process so we don't accidentally forget?
Absolutely. Python provides this really elegant and much safer way to handle files using what's called a context manager. And you access it with statement.
Okay.
So when you open a file using the syntax with OpenSF, the file is automatically closed for you as soon as you exit that with block. Automatically. And it doesn't matter what happens inside the block. Even if there are errors, that file will get closed. This eliminates the risk of forgetting to call close.
Nice. So it's like a built-in safety net.
Exactly. It makes your code cleaner, more reliable, just better overall. It's really the recommended way to handle file operations in Python.
Okay, so we've covered the theory, the concepts. Now let's make this real. See these ideas in action. Our source material provides some excellent examples to illustrate how this stuff works in practice.
Yeah, let's walk through them.
So the first example, it's just a basic task. Write some lines to a file and then read them back. Pretty straightforward.
Right. Example 1. It shows you how to use that with open statement in write mode, W, to create a new file and write 3 lines of text to it.
Simple enough.
Then it opens the same file again, this time in read mode, R, and uses the read method to grab all the content and print it to the console. It's a clear demonstration of the fundamental read-write workflow.
And then in example 2, we get to see how to process a file line by line, which, like we said before, is essential for handling larger data sets.
Exactly. In this example, the script first writes the numbers 1 through 10, each on a new line, to a file. Then it opens that file in read mode and uses a for loop to go through each line one at a time. And there's a little trick in there using the strip method.
Okay. What's that for?
So when you read a line from a file, it usually has that invisible new line character at the end. Removes that so we can cleanly convert the line to an integer without any issues. And finally, it calculates and prints the sum of those numbers. A nice example of how powerful it is to iterate through a file line by line.
And what about example 3? What does that show us?
Example 3 is all about the append mode, A. It demonstrates how to add data to a file without overwriting the existing content. It first creates a log file and writes an initial message to it. Then it opens the same file again, but this time in append mode, and adds a couple more log entries. Finally, it opens the file in read mode and prints the entire content, showing that those new entries were added to the end without messing up the original message.
Very cool. And the last example.
Example 4 gets a bit more fancy. It shows how to write data in a structured way to a file, creating a simple table of numbers, their squares, and their cubes. It uses this technique called fetch strings with formatting specifiers to make the output look nice and organized. This is a great example of how you can use Python to generate well-structured data that's both human-readable and easy for other programs to process.
Excellent. So to recap, we've covered a lot of ground here. We've talked about different file opening modes, how to read and write data in various ways, and why it's crucial to manage files properly, especially using that handy with statement.
Yeah, mastering these fundamental skills of Python file input-output is really a stepping stone to building more robust and efficient applications,
Hmm.
especially ones that need to work with data stored in files. It's a skill that keeps on giving in your programming journey.
For sure. So, listener, as you think about what we've discussed today, consider how you could apply these techniques in your own projects.
Right, like think about managing notes, processing data for tasks you're working on, or even creating configuration files for your own scripts.
What new doors does this open for you? That's something to ponder as you continue your Python adventures. Thanks for joining us on this deep dive.